I have returned to a function that I introduced in the last topic, y equals to x cubed minus 9x. And the way of writing this as a function in function notation typically would be something like this. We would write f parentheses x equals x to the third minus 9x. Now the f parentheses x, f is the generic letter for function. You can use other letters. For example, you could write g of x equals to negative 3x minus 4, for example. Or if you're representing, let's say, some kind of cost function, c of x for cost is, for example, 25x plus 1,000. All right, so we can use different letters to represent functions. But notice how I'm saying this. This is f of x. This is g of x, c of x. That's short for a function f of x, a function g of x, and so on. Or f is a function of x. So f of x is the short way of saying that. It's not never f times x. You know, if we had two letters f and x and want to multiply them together, we would just write fx without the parentheses. So it's a small abuse of our notation in algebra, but it's the way we always do functions. Okay, well, it has some practical value. For example, if I want to calculate f of 1. Okay, now f of 1 means take the input value, make the input value 1, and plug it into here. So it becomes 1 to the third minus 9 times 1. You notice how I like to use a lot of parentheses. That sort of organizes it well. And you can avoid errors, especially when you're dealing with negative numbers. We'll see that in a few minutes. Well, anyway, f of 1 is 1 cubed minus 9, so this would be 1 minus 9 is negative 8. As simple as that. Okay, well, let's try another one. F of negative 2. So if I plug negative 2 into here, I'm replacing x with negative 2. So it becomes negative 2 to the third power minus 9 times negative 2. So again, I'm using parentheses, which makes a lot more sense when you have negative numbers, I think. All right, so minus 2 to the third is minus 2 times minus 2 times minus 2. It's a minus 8. And then here I've got plus 18. The negatives cancel. And that equals to 10. All right, so one thing you can say, well, instead of saying, well, what is y when x is negative 2? You know, y is equal to 10 when x is negative 2. You could just simply say f of negative 2 equals to 10. Well, there are a lot of other practical reasons for using this notation, as you'll eventually learn if you keep taking math. And so it becomes a very handy way, concise way of representing a function, and it does have its advantages. All right, well, there are some pitfalls in calculating these, some mistakes, common mistakes students make. And remember what I said about common mistakes. If it's a common mistake, that means there's a good chance that you're going to make that. So I'm going to erase the board and show you a real popular common mistake. Here's my example. I changed the name of my function. I call it g. G of x equals to negative x squared minus 3x plus 7. And I'm going to plug in negative 2, in other words, negative 4. So let's calculate g of negative 4. All right, now watch how I do this. We have the negative sign, and then x. Negative x is replaced by negative 4. This is what this notation does. It replaces the input variable, which is kind of like a placeholder, with this number. So I'm replacing the x's with negative 4. So negative 4 is squared. So here is negative x squared, just like up there, except I replace x again with negative 4. Minus 3 times negative 4 plus 7. All right, well, if you've written that out correctly, then it should probably get it right. The the mistake a lot of people make is thinking that this is going to be positive because you're squaring x. Well, we are squaring x, but there's a negative applied to that. So this is negative, and then parentheses squared. Remember, the order of operations says to do the exponents before subtraction. So negative 4 squared is 16. And I kept that in parentheses deliberately here, just to really emphasize this problem with negative signs. All right, negative 3 times negative 4 is a positive 12, and then we have our plus 7. So let's say what we get. This is 19 minus 16 is 3. There we go. Now, I'm going to show you the wrong way, the way people screw this up a lot. All right, so let's draw a distinction here. And here is the wrong way of doing it. Okay. Well, g of negative 4 is negative 4 squared minus 3 times minus 4 plus 7. Let me clean up my 4 here. Kind of made that pretty sloppy. Okay. And then we get a positive 16 plus 12 plus 7. What is that? I think it's 35. All right. Well, if you thought, well, this is reasonable, I'm not going to make that mistake. Well, you better practice because you may forget this easily. That's the trap people fall into. They see something, they think, oh, that's reasonable. I'm not going to fall for that trap. No way, Jose. Will I do that? But oh, wait a minute. How come I keep seeing this kind of stuff on tests? So be careful about that. And it's about what we have to say about introducing functions for this course. Now we're going to go on to graphing linear functions, which is graphing lines.